I've always seen design as a thought, a dream, or a concept that has continually evolved, not a static single point-in-time representation of a model consisting of loss, fillets, and extrusions or drawings. Design is a process, it's not an end. It's a continual evolution of thought that must be captured and effectively communicated. In essence, design is only as useful as the designer's ability to capture and communicate a concept. Now I'm hitting the road to see how our customers are utilizing Autodesk technology to turn concept into reality. Hey, what's up everybody? Rob Cohee, Technical Evangelist for Autodesk Manufacturing, and today I'm in Newburgh, Oregon, home of ADEC, where Ken and Joanne Austin have been bringing some of the most revolutionary dental equipment solutions to market since 1964. Their vision of providing a quality environment where people work together for the betterment of dentistry worldwide permeates every aspect of their business and has created a culture of quality that is evident in every person that I've met with here at ADEC. And it's what they refer to as the ADEC way. Now I'm going to meet up with members of the ADEC team to see firsthand how their culture of quality impacts product design from engineering through to technical illustrations.
So we're going to start off in engineering. And I'm here with Patrick Berry. Patrick's a staff engineer, and he's going to tell us a little about what makes ADEC unique from an engineering point of view. Patrick,
hi.
Nice to see you again, man. So you were telling me yesterday about some of the things that you guys do inside of engineering that really that you infuse the quality of your products right at the start, right at the design phase inside of engineering. What are some of the things that you guys do to go about making sure that the engineering quality is at the level that you guys expect from a product?
I think the biggest thing is really just spending the time up front to do it. And catching a quality issue at the end of the line is the last place you ever want. It's the most expensive place to catch a design flaw or something like that. So by doing everything in this virtual world up front, we're able to anticipate a lot of these problems before we really committed a lot of very expensive resources to the problem.
You're able to take these digital models and print the physical models before they're actually parts, so that you can get people to kind of experience the feel of a handle, if you will. Why is that so important with your product line?
We're building a product that people work intimately with every day. And to get the feel of it, you can't just show someone a piece of paper and hope that they imagine what it's going to be like. You need to really produce it and then let people sit with it, hold it in their hand. See, if I have a grip, like a handle right here, I don't want to imagine what that's going to feel like in my hand. I really need to grab it. And you can't do that on paper. You lay it out on paper and you never quite get the scale of things. It always looks bigger and kind of off. And by being able to visualize these things, by being able to take this part, which this was an existing part, by having that in space, I could design around it. This allows us to simplify the product by taking what would have been dozens of different parts that have to be assembled.
Gotcha.
And every time you have a separate part, you have a separate assembly, you open a new potential source of error into the product.
So once engineering is done and you guys have been able to create both a digital prototype and rapid prototype, so you can kind of experience the design both visually as well as being able to feel those components. Once that's ready to go, you mentioned that you're going to send these models off to engineering. Now I understand you guys are using Vault to do that, correct?
Yeah. What you're seeing on the screen here, this represents the work of about 6 different people. I did most of the big cover components, the structural components and things like that. But someone else did the handle, someone else did the oil collector in the back, someone else did the control block. And all these people, we need to be able to share our work correctly. When it's involved, you've got that history right away, which that becomes invaluable, because sometimes you have to roll that back if you start experimenting with something and not working out. But it also means that when it's in there, everyone else who looks at it, they can have confidence that what they're going to be pulling out is what you consider the state of the art at the moment.
Yeah.
And then when it's in there, that becomes also a long-term repository.
So you guys really bear a pretty heavy burden from an engineering standpoint. You're creating essentially the intellectual property of ADEC, and that's being repurposed in almost every aspect of your organization. So what we're going to do next is we're going to head over to tooling and figure out how they're repurposing the designs that Patrick and team create for their tooling purposes. Thank you very much for your time.
Thank you.
And I'm sure I'll see you again.
All right.
All right, see you.
Stay tuned. After this, I'm going to head down to the machine shop and see how the engineering data is used to generate machining code.